Welcome to Lesson 2 homework. I'm going to probably be going through this a little bit faster than the first video because first of all, the first video is 17 minutes long and no one has time to watch 17 minutes. Oh my goodness, that's such a long video. And third of all, because you kind of already seen this now one time around and so you probably don't need me to go so slow. Now, if this is the first video that you're watching, I would encourage you to watch your homework number 1 video. It goes through this a lot slower, and I'm going to be kind of just going through the basics of this. Again, you want to be making a copy of your homework when you get it, and when you make a copy, you want to make sure that you include your name in the title so that I know that when you submit this, it's going to be your homework. Also, another thing is a reminder that you want to change the font color so I know what your work is versus what the actual problems are, and I want to see all of the work. So this homework is going to look very, very similar to the homework number 1, but you'll notice that the level of problems, the difficulty of problems, is a little bit more advanced. So we take it up a step. Okay, so the first section is evaluate the following. So we're going to be plugging in this -1 into the x values. So I have f of -1 is equal to 2, and then instead of having that x, I'm going to have -1, and I'm going to just use this caret button, squared plus 6. Now, if you wanted to, you could plug this into your equation, so you could click Insert Equation and do that. But I know that a lot of us are really busy, and if you write it just like this, I'll know exactly what you're doing. So if you want to just use the caret button, you can do that too. So when we're doing exponents, we do exponents first and then multiplication. So please do not do 2 times -1 first. We're going to do -1 squared, so -1 times -1, which is +1, and then +1 times 2. So I'm going to write all those steps for you. So I have -1 squared, which gives me 1, okay? And then I have 2 times 1, which gives me 2. And then 2 plus 6, which gives me 8. And then that would be my answer for this problem. Again, please make sure that you're showing me all of your work for every single problem and not just giving me the answer. Okay? All right, now on this one is very, very similar to number 1, except it just wants you to write it as an ordered paired point. So the only difference here is the fact that you have a different end answer. So you're still evaluating for f of 8. So you're still plugging it in for the x. And you're still multiplying this out. So 1/2 times 8 is same as 0.5 times 8, or 8 divided by 2. So that would give you 4. And then 4 plus 3 gives me 7. So instead of me leaving it as f of 8 equals 7, what I need to do is I need to write it as an ordered paired point. So 8, 7. And that would be my final answer. So it's very, very similar to number 1, except now you're just going one step further and you're plugging in, rewriting it in as 8, 7. Okay. So perimeter, again, you know how this works. You're going to add up all of the sides and combine your like terms. Now, the one thing that you have to be careful about here is notice that these two sides are not given. So what that means, to figure out these two sides, you have to do some subtraction, okay? So instead of me doing this problem for you, what I'm going to do is I'm going to start the second problem for you so that you have a little bit of an idea as to what is going on here. So you're going to start by combining your sides. So you have x, whoops, hold on, let's check out the formatting. So you have x squared minus 2x plus 15, that's the bottom one right here, plus 3x plus 4, plus, now here's the thing, we need this side. So this side is going to be this long side minus this part. So I'm going to put parentheses so that you can see this. So it's x squared minus 2x plus 15. Oops. And then we have to have parentheses around that too. So double set of parentheses. Yay. Minus parentheses negative 5x plus 12. Okay, so that is for this side here. And then plus, you have this side right here on this top height. So that's going to be the parentheses 8x plus 6 minus 3x plus 4. Now, the reason why I'm having all of these parentheses here, and I'm going to actually just tab this back out so that we can fit the whole thing in, is that you have to make sure that when you're combining these two inside the parentheses, is that you have to distribute this negative sign in here. So when you're minusing this, minus negative 5 is actually going to be plus 5x, and minus positive 12 is actually going to be minus 12. So think about your PEMDAS, okay? So you're going to want to make sure that you do your parentheses items first, and then you're going to do everything else and combine your like terms, okay? So this is your expression that you're combining. Do the parentheses first, so this first set of parentheses here and the second set of the parentheses here. Then go ahead and combine your like terms and simplify from that point, okay? All right, area. Oof, my formatting got a little bit messy, so let's go ahead and bring this all to one side so we can kind of see it. All right, so you know how to do this one, length times width for the area. For this one, they give you this piece of information here that is really irrelevant when it comes to area for this triangle. All it is your base times height. And this one, we don't even need to divide by 2 because there's 2 triangles here. So it's just base times height. Now, on the triangle, one thing I'm going to remind you about is that when we distribute two different factors or two binomials, we have to distribute into everything. So it's going to be 2x times x, which will be 2x squared. So 2x times x, 2x squared. Then 2x times 2, which is 4x. So remember, we distribute the 2x to the first term and to the second term. Then we distribute the negative 5 into both terms. So negative 5 times x is negative 5x. And then negative 5 times 2 is negative 10. Again, I'm going to change this to be blue font. Okay, and then from there, I can combine my x's. So 4x minus 5x is negative x. So we have 2x squared minus 1x minus 10. And that is going to be my answer here for the area. So equals area. Okay, on this one, it says find the missing sides based on the information given. So this is very similar to our perimeter problems, but you're just going to have to use your brain a little bit more. So this problem is a lot like how I explained this problem. Okay, so you're going to be having to subtract some sides to get the other side. So for instance, this longer side minus this shorter side will give me this shorter side here. And this longer side minus this shorter side will give me this side here. This one, it says that the perimeter, so the total of the sides, is 6x minus 4. And it gives you these 3 sides. So if you took 6x minus 4 and subtracted these other 3 sides, you could get this base piece. And then this last one is the one I'm going to show to you. So notice that they have these tick marks. What that means is all of the double tick marks are going to be x minus 6. And my entire perimeter is 9x. So I can say 9x minus, now I have 3 double tick marks. So 3 of the x minus 6. Now, could I just write x minus 6 3 times? Absolutely. I'm not going to do that, okay? So I'm going to start there. What's going to happen is that will give me a result, which will be these 2 sides here. And so we'll divide by 2. So before I do 9x minus this value, I want to distribute the 3 in. So that's going to give me 9x minus, and then 3 times x is 3x. And then 3 times negative 6 is negative 18. Okay? And then when I'm doing this, I distribute the negative in, right? So 9x minus 3x is 6x. And remember, 2 negatives equal a positive, so we'll have plus 18. So, whoops, this formatting again went a little bit weird. So what I just did was my entire perimeter is 9x. I know that all these double markers are x minus 6. So it says find the missing sides. All of the double markers are x minus 6. What I'm trying to do is find what are the sides of these single tick marks. So I know that both of them combined together give me 6x plus 18 because I took the total perimeter and subtracted the other three sides. So if I know both of them are 6x plus 18, what I can do is I can take 6x plus 18 and I can divide it by 2. Okay, so 6x plus 18 divided by 2. And then that will equal 3x plus 9. So these are single tick marks. And then we know that the x minus 6 are double tick marks. So I am just writing down what each of the sides are. So 3x plus 9 are the single tick marks, and then x minus 6 are the double tick marks. Okay. All right, so we again kind of talked about this in the last video. Just find the next two values. I am going to just briefly talk to you about these fractions. So fractions can be a little bit difficult, but how we look at them is notice that these bottom two have 2's on the bottom. So I want you to ignore the 2 on the bottom. Just look at the 7 to 5 to 3. You'll notice that we're minusing 2 every single time. So what that means, if we're minusing 2 on the top, we're essentially just subtracting minus 2 over 2. So if I wanted to continue this one on and do it, sorry, I keep on forgetting to change this color. So we have 7 over 2, 5 over 2, 3 over 2. Now what's 3 minus 2? Oh, it's 1. And then we just put it over 2. And then what's 1 minus 2? Oh, it's negative 1. And then we put it over 2. Okay, so we can say we noticed the numerator, which is the top, was subtracting 2 each time. And we can just leave it as that. So we noticed the top was subtracting 2 each time. So now we just took the top and subtracted 2 each time. And we kept the bottom consistent. Kept the bottom as 2 because all the bottoms were 2. We can do the same thing with this one. What do we notice about the top? And then the bottom's always going to be 2. Now on this one, you'll notice that the top is always 3. So ignore the top and just focus on the bottom. So how do I get from 5 to 10? How do I get from 10 to 20? And then we're going to always have 3 on the top. So it'll be 3 over what's going to be on the bottom. Okay? All right. Next one is again just kind of more talking about what you know. So how do you know if an equation is a function? We talked about that on our video 1. How can you tell if a pattern is arithmetic? Arithmetic patterns have a graph that is a blank model. How can you find the rate of change in a graph? Okay, so these questions just answer in a complete sentence. All right. This is very, very similar to number 1. The one that I'm going to talk to you about, though, are these end ones. So f of negative 1, you're just plugging negative 1 in for x. G of negative 2, just plugging in negative 2 for x, but for the g function. These ones might be a little bit confusing for you. So these two, so this one and the last one, are asking you to plug in 3 to the f, plug in 5 to the g, and then add them together. So I'm going to show you that one. So we're doing the f of 3 plus g of 5. Okay, so we're plugging in 3 for the x. So we have 3 times 3 minus 4, so that's this part right here. And then plus, we're going to put 5 in for the x here. So we have 5 squared plus 1. So now we have this long extension that we're just going to combine together. Okay, so f of 3 plus g of 5 equals, okay, remember we know we do exponents first and then multiplication, so 3 times 3 is 9, And then 5 squared is 25. Oops, got the plus sign. Okay, and now we're going to just add and subtract left to right. So 9 minus 4 is 5. So 5 plus 25 is 30. 30 plus 1 is 31. Okay, so that would be our answer. Now, you would do the same thing for this one, except with the minus. Now, on this one's a little bit confusing. It's f plus g, 4. So what they want you to do is they want you to combine your functions first. So they want you to do, so hold on, let me put this one in. So f plus g, 4. What you're going to do is you're going to do 3x minus 4 plus x squared plus 1 first. Then you're going to plug in 4 to the equation. Now, honestly, guys, this is not going to really change this very much because you don't have a lot of things to combine here. Now, in another case, it might change the equation quite a bit. So, for instance, we can't combine x squared, we can't combine 3x, and we could combine negative 4 and 1, so that's going to give us negative 3. Then, now what we're going to do is we're going to plug in 4 in for x. So now instead of x, we'll have 4 squared plus 3 times 4 minus 3. Okay, and then you'll evaluate that. So keep going from that part, okay, and just what's 4 squared, what's 3 times 4, and then combine them together. Okay, so we went over this before, so I'm going to quickly go through this, just factoring. So this is just distributing it in. And again, if you want to change any of these to decimals, you can. So just multiply this into both and tell me what you get. Again, if you want to change 1/5 into a fraction, you can, or into a decimal, you can. Just multiply it to everything and then tell me what you get. Distributive property, we're going to distribute out our largest factor. Notice that all of our GCFs here are already stated. So we're going to be taking out the x from the x squared minus 2x, so dividing each. So on this one, just in case you forget what this is, remember x squared divided by x is just x, and then negative 2x divided by x is just negative 2, okay? And then do the rest for this. Please make sure that you answer this question. So use complete sentences for explaining what you've noticed in factoring so far. Oof, okay, so what we're going to be doing is we're going to be looking at these and just explaining answers to them, okay? So when factoring the expression, Sarah says that you can take 2 out from each of the parts. Rogelio says that you can take 4 out. Which student is correct? Okay, so explain who is correct. Which student is more efficient? So you should probably have 2 or 3 sentences. Joni says that the following expressions are all equivalent. Tell what you think about Joni's claim. So essentially, what she means if they're all equivalent is that if I multiplied 4 into here, I multiplied 8 into here, I multiplied 2 into here, they would all give me 8x minus 32. So is that true or is that false? And then lastly, using what you've learned about factoring and equivalence, write as many expressions as you can that's possible to hear. Now, on this one, please make sure you can just use whole numbers. Otherwise, there's an infinite amount of possibilities if you go into fractions, decimals, everything. So just use whole numbers here and it will be a lot easier. Okay, so that's the second homework, a little bit lengthier. That's why you have a little bit more time on this. And again, please reach out to me if you have any questions.